So I've got my task 4.1 here. So basically I've got my report sheet, and then I've got my solution here. So I've just gone through all the different exception types as requested by the task sheet document. So a null reference exception. This is where you try to access the content of a reference and there's actually nothing, there's no variable or object instance being referenced. So one easy way to produce this is you would set a instance of a class or a reference to null, and then you would try and call a function within it, and then that will call the null reference error. And you can see that I've got a couple of helper classes up here that will just help me diagnose some of these, provide examples. So I've added a little test here just to stop it from happening. That's how you should have it, but yeah, it will display this message if you didn't have this test. Index out of range. This happens when you try to access an element that's either greater than the size of the array or less than zero. So the easiest way to do this would be to create an array of the size of a certain size. This is 5, and it's going to iterate through each one, and it will be fine until it goes past the size of the array, which it will do because I've got the +1 here. And then you'll get this index out of range section. You would fix it by removing this +1 from that line. A stack overflow exception. So this is when the stack overflows. You got heap and stack memory. Well, this happens generally when you have a function that keeps calling upon itself ongoing forever. So definitely the easiest way to produce this is just to create a simple void function, or any function that calls itself with no check at all. The best way to sort of avoid this happening would be to have this function keep track of how many iterations it's done, starting at 0, and then if it's below a certain amount of iterations, it will stop calling itself. But yeah, you won't actually get a you won't get an exception for this. You can't anticipate it. You can't catch it, as far as my experience is anyway. The program will fail before then. An out of memory exception. Well, this is technically when there's not enough memory that can be assigned to a variable. I believe that the limit is something like 2 gigabytes. Couldn't get it to happen on my end, but one way to do this would be to have any variable that keeps increasing in size. So a string is essentially, I guess, a list of characters, if you look at it that way. And if you just kept adding to that list of characters just forever, eventually you would get this out of memory error, and you can't catch it either. It's not something that the programmer should try and catch. You just have to avoid it. Invalid cast exception. So the easiest way to create this is basically where you have a base class and then a derived class and another derived class of the base. So it makes sense that the dog class is also animal. Dog is type of animal, and cat is type of animal, but a dog is not a type of cat. So if you try and assign this dog that's that's held with an animal reference, you try and cast that to a cat, it's going to have an invalid cast exception. You shouldn't really try and catch that. You should try and check first whether it actually can become, cat. And a good way to do that is to check if the reference itself actually is a cat. Divide by 0. Well, this one's pretty self-explanatory. If you try and divide any number by 0, if it's not held in a variable, the compiler won't let you run the code anyway. But if it is held in a variable, you'll get this divide by 0 exception error. The easiest way to avoid this is to check before you go to divide something by a variable. Make sure that the variable isn't actually equal to 0. An argument exception. So this is something that is generally defined by the user when it should occur. You put it in a method, and the method basically is saying, there's something wrong with one of the arguments you provided. So an example of this is, what have I got? What did I decide was wrong with that? Yes, you can also set the custom message that it'll come up with. Yeah, you cannot deposit a negative amount, so it makes sense that someone could not deposit a negative amount. Whereas this error here, it's very similar to a argument exception, but the main difference being that this generally refers to something that's not so much wrong, or how would you call it? It's not so much inappropriate, or also not so much that it doesn't make logical sense. It's more that it's outside of a given range that's expected. So a good example of that is, say, deposits were limited to less than $1 million. So if they were limited to less than $1 million, you could throw an error, just an exception, which is contained in the method, just saying what the limit is, and then the user knows that they have to be within that limit. Okay, so system exception. Basically, every exception derived from exception. That's the base class of all of them. System exception, as far as I understand, is a derived class of the exception class. So if something is thrown by the system, it will be derived from system exception. If it's sort of custom created by the user, you would generally a custom created exception would generally be derived directly from exception. So in a use case scenario, generally if you want to tell if something is a system derived exception, system thrown exception, you could run code like this that would check, if the exception is a system exception, or else it's thrown by the application, not the system. And all my code that's pretty much been included in the report is here, and I've just got these sort of classes that I used for my testing. So that's pretty much it for that.